There are many man-made materials used in modern medicine. Titanium alloys, hydrogels, 3D printed body parts. And coming soon, a wondrous new material courtesy of our little friends. Presenting worm spit. Yes, the dried husks of worm spit. But don't take our word on it. Dr. David Kaplan has over 30 years of experience engineering medical materials.
I've never seen or found or worked with any other material from nature that offers the versatility and range of properties.
From their lips to your body. It's an all-natural solution, made from a protein called fibrin.
I guess scientifically that would be a more accurate term, but the people are more familiar with the term silk.
Ah, silk. Now that's something that you and they can get wrapped up in. Putting silk to work as a medical material is not novel.
Silk sutures have been approved by the FDA and used for centuries in patients, and yet there were essentially no other medical devices being made from silk until we started about 15 years ago.
At the Tissue Engineering Resource Center at Tufts University, creating medical-grade silk from silkworm cocoons begins a little like cooking.
We first had to sort of extract and clean them up so they'd be safe to use in vivo or with cells. So that involves basically a salt extraction, right temperature and time. After that, we're left with the pure core fibroin fibers, and those have to be essentially reverse engineered back into aqueous solution. So for that, we use a high concentration of lithium salts in our lab. We now have a solution of the silk with the salt, which we then dialyze to remove all of the salt. And then you're left with just a pure water solution of the silk protein.
And this is where silk becomes an incredibly versatile material.
So for example, we can make everything from nano and microparticles for injectable drug delivery applications. We make solid plates and screws for orthopedic repair devices. We've designed and built in the lab a three-dimensional mammalian brain.
Not a complete brain, a 100% functional portion of a brain.
Where you have a porous matrix on the rims to house the cortical neuron cells. And in the center of the donut, which is normally hollow, we fill it with a gel, and this gel supports the neural outgrowth to form the connections that you'd want to see as if it was a true brain that we can maintain for months at a time, which is quite unusual.
The list goes on, from silk intestinal models to silk adhesives. But versatility and durability aren't the secret to the silk sauce.
It's unusual. Silk is surprisingly low in terms of its biological activation, meaning low inflammatory response and almost a non-existent immune response in the human body.
Although just because your body doesn't want to kick it out, doesn't mean the silk is meant to stay there.
Silk is not intended to be a permanent fixture in the human body. It's made to degrade away within a day, a week, a month, a year, a couple of years maximum.
But that's not necessarily a bad thing. Take, for example, the use of orthopedic screws.
That could fix ligaments to bone and bone to bone that would go away in a program lifetime, particularly for children
whose bones are still growing. Having the screws or any implantable silk dissolve at a specific rate also provides another subtle benefit.
To load the devices as well with medications as needed, so they're locally delivered to help in the healing process.
By now you're probably thinking, this all sounds wonderful. Why haven't I heard about this from my doctor?
You know, all these are still early stage because all the technology we're talking about is only in the last 10 years or so. And it takes, good 10 to 20 years before you start to see the real inroads into medical devices.
That hasn't stopped Dr. Kaplan and his team from creating more and more uses for silk. Implantable silk biosensors? Working on it. Silk optics? Working on it. Silk breast implants? Yep, they're going there.
Every time I think I've learned everything we could know about silk, there's something new discovered by one of the students. So my hope is, when I get even older and need my repairs, silk will be an option that I can choose when I go to the hospital.
For Science Friday, I'm Luke Groskin.